Okay, I'm gonna do a video that shows a basic overview of structs and some of the things you can do with them, just because I think maybe people haven't touched them in a while, or maybe you haven't seen it before. So here, I just have a struct node that is basically for a simple linked list implementation. It just has a integer field, a string field, and then a pointer for next. What you'll notice here is that I have these values initialized to like a default value. So you don't have to do this, but I think it's good. Well, at least I like to do it because, that way if you're doing your project and you try to initialize something and you print whatever you've done, you can tell pretty easily if things are getting initialized correctly or not. You don't have to do these. Like, you could leave the num field and the name field uninitialized if you want. Although I do think having pointers initialized to null by default is good practice. Just because, if you're ever trying to iterate through anything, then unless you explicitly change your pointer, then you know that it will be null terminated, and you can avoid your program crashing that way, and trying to track that down. So I'll reset these defaults. Okay, and then I just have a function header for a print struct statement, and then some include guards. So the print statement is not that interesting. It just prints out the fields, and then if the next pointer in the struct is null, it'll say next is null. Otherwise, it'll print the name of the struct, the next node anyway. So if we go to main, so the first thing I want to show you is some ways to initialize these. Okay, so here, this is just to showcase the default values. Here, we're just going to update number, and we're going to leave name in the pointer alone. Here, we're going to update the number and the name, and then we're going to leave the pointer alone. And then this one, we're going to update all three fields at once. This should be my struct. Okay. And then we'll print these out so you can see what's going on with those. Here, this is something to note. So you see you don't have to update all the fields or any of them if you don't want in this example, since they're all initialized already. But one thing you need to know is this won't work, because basically what you're saying here is you want to initialize the first field in the struct to be whatever you pass, right? And in this case, if you look, the first field we have is an integer, and you cannot obviously assign a string to an integer, so this won't work. So you can update just one or two or however many you want at a time. You just have to be mindful that what you're passing is in order of how they appear inside the struct itself. So if we compile this, you can see here this one is all just default values. This one we updated number to be 20. This one we updated number to be 10, and we gave it a name example struct. And then for the last one, we said example struct 2, number is 30, and this one is pointing at example struct because we told it to. So those are some things you can do. Something else you might want to know is that you can point at something that is allocated. So here, what we're doing is, these are all default values. We haven't changed anything. We're allocating a new struct, and we're updating the node to have number 5 and the name Alina. And we're going to say the next pointer for the struct we have up here is going to equal this struct. And then we're going to print both of them so you can see that. One thing to note is, because this is a pointer and this is also a pointer, we don't need to add the address, because these are both pointers, so we can assign directly, unlike the last example. And then also here, obviously, because this is a pointer, we need the dereference, because this function takes the struct itself and not a pointer. So that's something to note. So if we run this, so you can see that before we do anything, this is all default, and then once we initialize the next to be the node that we allocated, you can see that the next node is Alina, and then this is the node we allocated. One thing you can do is you can create a node directly from the node you already have. So here, we're saying, okay, mystruct1 is our node, and then we're going to say mystruct1.next, so this is a pointer, is going to equal a new example. So now we're allocating memory for this node, the next node, directly by accessing the next field in the first struct we created. So again, the output is going to be the same just because these values are the same, but and then again, because this is a pointer, we need to we need to dereference, but you'll notice that we don't call this mystruct2 because we didn't create mystruct2. All we know this node to be called is mystruct1.next. So if we run this, the output is the same, but you know, it's just a different way of doing it. And then, so another thing that might be good to know is how to do this in like a loop, or how to allocate things. So here we allocate, you know, an array of 10 nodes. If you were doing C, it would look something like, if I could spell. Maybe that doesn't compile, but this is the idea. So that, you know, once you do this, or one of these two things, you can access these array indexes directly using, you know, bracket notation like you would any other array. So they're nothing to be afraid of. I don't know, a lot of people in their projects were scared of allocating memory, but it's not too bad. So here we're just initializing all the values, you know, iteratively through the array. We're going, you know, through each position and updating the number field and the name. And this name is just going to be the letter capital A, and then it's going to increment one letter at a time just because these are ASCII values. And then we're going to print all these out. So if we compile this, oh, I didn't save it. Okay, so now you'll see. So A0, B10, C20, D30, you know, all the way down to J90. And then all these next are null, and that makes sense because we didn't initialize the pointers for anything. But if we wanted to do something like that, we could do something like this. And this is just a fancy way of saying that we want array index I to point at the next thing in the index, but obviously we don't have an index 10, so we do mod 10 to wrap back around. So basically this is going to say once you get to the end of the array, we want the thing at A of 9, or array of 9, to point back at array 0. That's all. So so if we run that, you can see A0 is pointing to B, B is pointing to C, C points to D all the way down, and then we get to J, and J is pointing back at A. So hopefully that's enough to get you started. I think that should cover pretty much most of what you need to do as far as structs are concerned. So hopefully this helps.